All right, full screen. All right. Okay, my name is Joonas Pajunen. I don't think I have my full name here in my slides. So there's that. My topic today is Claude Code and in more general way, agentic AI and how to develop stuff with agents. Um, First, a little bit about myself and how I ended up here in this situation. I have software development experience for roughly a decade's worth of time. That was in the 2010s mostly. But since 2020, I've been the CEO at Fractio. But during the last maybe year or so, I've been doing a little bit of development even for our customers. So Fractio is a consultancy or an agency, just like Wunderdog here, and we build software for our clients. And I've been doing that a little bit myself, just to try out these tools and see where this technology is headed. I've been using, I've been doing prompting before ChatGPT. Used Midjourney when it was in beta, GPT-3 in text editor, and then LLMs, of course, when everyone else is started using them. On coding wise, I've tested out Cursor. I like Replit a lot, especially for like teaching purposes, and its agent is pretty effective. Recently, since June or July, I've used Claude Code quite a lot and tested out some other agent configurations as well. And there's this meetup called Vibe Coding Finland that me and well, mostly my friend Jesse set up this maybe February or something. So I've been helping out with that. And through that also I've been exposed to lots of different people doing lots of crazy stuff with just agentic AI and vibe coded stuff. Um, Lots of you do use AI. I like to think this in these three different categories: AI assistant development, and where you have an AI as your like pair programmer or an assistant. Then vibe coding, where you don't look at the code at all and you just go with the vibes. And then a agentic AI development that falls somewhere in the middle of those two. And that position in the middle of those two is autonomic AI, and it requires guardrails, which I will be talking about today. So I assume many of you use AI like these co-pilot tools, autocomplete tools. Do raise your hands if you use AI in this way. Yeah. They work as an autocomplete, or maybe you copy and paste stuff. I've been hearing from some senior programmers lately that they've stopped using autocomplete because they feel they don't have enough control, and they just reverted back to asking for help and then copy pasting if necessary. I'll come back to that like worldview later. Then there's vibe coding. The idea is that you don't really look at the code at all. You assume it works. If it doesn't work, you tell the machine, the AI or something, that it doesn't work and you need to fix it. You can get quite far these days, but you need to keep these things quite small. You may end up in a dead end if you don't know what you're doing. But these agents are improving and pushing the envelope, pushing what's actually possible with them. I mentioned tools like Replit and Lovable, of course, the Swedish alternative. And then agentic coding. I think I currently look at it at like vibe coding, but somewhere more serious. Uh, Agent, this is not like the official description, but agent is an autonomous AI that has the ability to use different tools and fetch data from well, anywhere or somewhere you uh, configured it to. It's like a harnessed vibe coding entity. Now, there are different tools, but I'm today talking about Claude Code. Yep. It's command line interface tool that runs Claude models. So Claude is the like a series of models from Anthropic. They have the Opus, Haiku, and Sonnet models, and you can basically use run them on your from your local machine. They, of course, you don't really run them locally. You expose your local file system to these tools, and via that, you have an agent operating on your own machine. In a sense, of course, everything runs in the cloud, but the agent architecture pushes your local file system or exposes your local file system to the models in the cloud. So that's how it basically works. Because it runs locally, it's pretty customizable and extendable, and you can do like local tricks with it compared to like Replit, which runs completely in the cloud in their own environment. Compared to other competitors, I believe it's the most feature rich. At least it has the first mover advantage. Oh, I forgot to mention, if you have some questions, you can ask questions like during my talk. I will try to leave some room for them in the end too. In addition to Claude Code being able to manipulate your file system and the files, it can run any command line tool, and that gives it much power. I'll show you something later. Because it's a large language model based tool, I will not be doing like live coding here with it because I have no control over how long it takes to answer anything. So we could be end up here waiting 5 minutes for something to happen. So that's not really how I want this to go. But it's very easy to install one command, and it should be up and running. You can install it via npm or a package manager too. And after that, you just say Claude, and you have a chatbot of sorts running. Looks pretty similar to any web-based chat interface. It doesn't really have any like intro setups or these sort of like any kind of like an way that gets me to the usage flow. It just offers an example. Try to chat something or press question mark to show some commands. And there's this like a bunch of different commands that you can use, and via them it becomes very powerful. I'll have some more screenshots describing how. The idea is that Claude has the ability to look at anything you have in the browser, in the folder you launch it from, or any subfolder. So it's like constrained or sandboxed into that folder. So usually it's your like project root folder, and it'll always ask for permission when it tries to do something. In here, it's actually doing something with GitHub. I'll get more to that later, but first time you run it, it asks if this folder is secure, or can I trust this stuff in this folder? You of course say yes. then it'll ask, is it okay to modify this file here? And you say, of course, yes. And if you don't want to be pushing yes every time, you just say yes and don't ask again for this type of command. Of course, I recommend you to, when first trying out this, I recommend you to closely monitor what it's trying to do and try to learn from it also. And avoid just blindly saying yes and yes, yes, yes. That doesn't really, well, you can do that, but you may like lose a bit of touch with what you're actually doing there or the agent is doing. Claude gives you tips while it's doing something. Here, for example, it says press. Okay, what's happening here? I've in the topmost screenshot, I'm in a branch and I say, what is the status of this issue? Is there a pull request? It's looking at the current branch and then it's checking GitHub. It says, yeah, there's an open pull request for this issue. It says press Control O to show what it's actually doing in a verbose mode. So you can have a very detailed view of what's going on inside the agent structure. Then it's giving you, like in the bottom here, it's giving you like different kinds of tips. I'll press S twice to rewind the code and the conversation to a previous point in time. So the usage, I think their design philosophy is that you should just be able to start using it and learn while you're using it. That's the point here. It's very easy. For me, it was very natural to just launch my terminal window and start using it, trying out and learn while I go. Context. Context is probably the most important thing when working with large language models. I think our job as the managers of these models is to provide the right kind of context, and the context means the chat so far that we've had, and every selected piece of code that we are working with. And Claude uses up that context every time I make some input and it gives me an output. It becomes part of the context. And Claude compresses it automatically and makes sure that the context doesn't overflow. So there's like a automatic compression, and you can explicitly clear it if you want to move on to say another topic, another feature or something. And then Claude has memory, which is also automatically loaded up into the context, meaning every command I give Claude, it will read the context file. So it could contain information how this project should be developed, what are our conventions there, how to do code formatting, or how to describe a pull request when it gets there, and that sort of stuff, or what's the project structure or something like that. I can also have personal context files if I have some personal stuff that is not shared with the team working also with Claude Code in this repository. And I can use this hashtag to say to Claude that please don't ever run the scripts here in this project. We don't want actual data to end up inside local large language models. I'll come to the security issue later. Claude has plugins, which is basically you can install plugins that allow you to use stuff from other people. I'll get to that later. I think agents is one of the most interesting ways to manage Claude. So, for example, I can Claude is how should I explain this? Claude code runs in this one chat, but if I want to do something very specific, I can create a sub agent that Claude Code can launch to do something specific related to my needs. So, for example, I can create front end or back end or security roles, security sub agents that represent roles. It's for me, I kind of found myself creating these roles that usually happen or exist in software development projects. I'm not sure if that's the like correct way to use this, but I found it to be obvious. And you have their own contexts. They don't see what each other are doing. So I'll show later how you can use them. This is from one of my one of my projects. I have a bunch of project agents there. It's an app that is for Brazilian Jiu-Jitsu coaches, and these agents do different things. It's pretty self-explanatory what a DevOps agent does or what a security agent does. Then there's plugin agents that I actually just installed yesterday. I haven't had much time to actually use them, but they appear like so. And next I'll get to, after this, I'll show a demo of sorts. It's screenshots because of the nature of LLMs and the waiting time. But Claude Code should implicitly understand which agent is good for any given task I tell it to. So, but also I can explicitly command Claude Code to delegate any work to these specific agents. So, for example, I can say put front-end agent to work on that issue, and then let back-end agent to continue from it, and possibly like a security agent to review everything. And these agents can work parallel or in sequence, or you can even set up like sequential loops where they talk with each other. So, yeah. Sure. Yeah.
About the parallelization part.
Yep.
So I know that Anthropic doesn't support parallelization like officially. It's not documented how to do it. So
Yep.
how do you do parallelization with Cloud Code agents?
Yeah. Do you mean like parallel, like working with parallel branches and doing like different features?
Well, what did you mean?
Oh, in here, these agents can do like the same thing parallelly, and then another agent can evaluate which solution is better, for example. So they work in the same space.
Yes. And
Yes.
how do you trigger that?
Just to saying to Cloud Code that you should like work in parallel. Maybe they yeah, your point being that they cannot be parallelly doing file system changes, because that will mess up everything. So in this case, it would be like do a plan. Two agents make a plan in parallel. I'll get back to the actual parallel building later. So demo here. I tell Cloud Code create a new branch. Let's work on. Oh, so this is the coaching app I mentioned earlier. So I'll tell Cloud Code to create a new branch. Let's work on a Halloween theme for the landing page. Get UX engineer to design a snappy pumpkin monsters theme, and then the front end agent to implement the design. Then let them review each other's work until they are happy with the result. So here, Claude Code first like replies what it understood this assignment to be. Then here it checks out a new branch and tells the UX engineer to do stuff. Then the UX engineer says, okay, I'll design this landing page and so forth. Then we'll wait for some time. Then we move on to okay, actually here the front-end agent is also working on that stuff. Currently in this screenshot doing some Tailwind configurations. Then next, the UX engineer reviews the implementation. Claude Code, the main agent is saying, okay, excellent review. The UX engineer identified several critical issues and so forth, and pushes them back to the front-end agent, and they work this like back and forth for a while. Here's a good example how Claude Code, and in this situation, the front-end agent creates a list of tasks that it will, like a plan for itself, that it will follow. And here, what's happening, the front-end engineer does stuff, then the UX engineer is doing like a final implementation review. So here's like 2 passes. And then Claude Code, the main agent tells me that excellent, everything is fine, and it gives me a summary of what happened and what's going on. And then for me, it tells me to, okay, you need to test this in my local environment. That is like a Dockerized environment. I say exclamation mark, which lets me run stuff directly into in Bash. So I'll start up the environment. I did that. I got like a HTML error or JavaScript error that it's broken. I tell that to Claude that put front-end engineer to investigate and use Playwright, which is like a Puppeteer or Selenium wave, like an RPA thingy that the agent can use to see what's in my browser. I'll get to the technology later. And here, the front-end agent launches a browser and asks me if it can use the Playwright tool and get console messages. And I say yes. It figures out what's wrong, and next up, it fixes whatever is wrong. So my job here is to only like give it permissions. I could also run Claude Code in a don't ever ask permissions mode, but that's kind of like a bit dangerous. So I didn't really have to look at the code at this point, but it's very difficult. I couldn't have managed this just vibing and telling it's not working, and it's a much more elaborate kind of workflow. And then I say, okay, make a pull request, and make a pull request. It does a commit, describes the code changes, and it creates a pull request to GitHub. So I wrote none of the code. The pull request is in my name, but later it says implemented with Claude or something like that. All right. Next, let's get back to the other useful stuff. There are custom commands you can configure, just like those sub-agents. Like for example, for testing purposes, I made like this prioritize command that fetches stuff from GitHub, compares to my local changes, and looks for like to-do comments and stuff from the code base. I haven't used them that much. And this MCP, a term that you know, it stands for Model Context Protocol. It's kind of like an API system for LLMs to use that that's not an official definition, but that's for me to like wrap my head around it, and for you to maybe get some kind of like an understanding what it means. But it allows Cloud Code or any other agent to access third-party tools and services. For example, project management tools, Figma, databases, browsers, or like digital audio workstations, if that's your thing. And in the example I just showed you, it was Playwright MCP, which allows it to use browsers. And this it has 21 different tools. It can like close the browser, resize the window, get messages, and so forth. There are other stuff. There are hooks that you can use to like configure like Slack messages or stuff. I'm really sure. It has some kind of a built-in sandbox mechanism that I haven't used or like tested out. There are Claude skills that are also in Claude like web and in the web app. I haven't used those either, and you can connect it to your IDE. So if you like prefer to look at the code like a proper engineer, and let's say you open a package JSON, then Claude knows where you are within that file or in the project, and then you can like ask questions about that file and so forth. The parallelization with agents, there are different tools that give you a nice graphical user interface on how to run several instances. In the background, it uses git work tree command, which basically just copies your source code to another folder and works in there. So there are no like clashes of file system changes. So in a sense, you can run like unlimited amount of Claude Code instances working on different issues of your project. The limit is probably how much your brain can handle, and maybe how much like review changes your team can handle. There are GitHub apps, like I mentioned earlier. You can use the GitHub command line interface tool is pretty powerful. You can like list, read, add, close, do anything with GitHub issues. So there's your like project management tooling. You can do anything with pull requests. You can create them. You can make Claude review them. And you can configure GitHub Actions to build your CI or CD pipelines. And then if you configure the GitHub bot app or something along those lines, it has access to Claude via API, so it's built in a different way. Then you can just say add Claude to your GitHub. Let's say this is probably, this is an issue in GitHub. I can say add Claude, implement this feature based on the issue description, and then it runs everything in not on my local setup, but in the cloud, in the cloud, using the Claude MD memory file and the proper instructions. So there's like a couple of different ways you can run this in addition to your local laptop. And then it just creates a branch and pull request here. There's another example. Oh yeah, that same bot will automatically do reviews on all your pull requests. You can of course configure it to not do those or do them only like in certain situations and so forth. There are web and mobile versions of this. I haven't used them that much. They are pretty new, released like a few weeks ago or something, but you can like forget the CLI and work on your phone if you really want to. But they happen, of course, in the cloud then. Other use cases, of course, you can run Claude Code on a server, access it anywhere. For me, the Claude Code CLI tools were kind of like an eye opener when I managed to create GitHub actions that I had not even touched before. I knew they are a thing, they exist, and I could just like make them happen. The same goes with Google Cloud environment. Everything can be configured via command line interface. So I could like become a DevOps person in a way. Yeah, people use Claude because it's an agent system on your local file system. You can do other stuff than code. For example, look at my thousands of notes, which are MD files, or sales proposal request materials, meaning lots of PDFs and Excels, and analyze them. And I guess the sky is the limit what you can actually do with this system if you are willing to open your terminal, and that's a put off for many, of course. Pricing is like 20 euros per month, the pro plan. You need that if you want to try out Claude Code. You cannot use it with the free version. If you are like a heavy user, you maybe need to go for the 100. I guess it starts from 90 euros, I think, the Claude Max. But for me, my day job is not like 8 hours software development, so I could manage with the pro version. I hit a limit after roughly 1 hour, but those limits are reset in like a few times a day and in a week. There's like lots of different limit tiers in there. And of course, you can use the API in a pay-as-you-go fashion. And if you use the Claude bot, that also in GitHub that uses the API, so it's an expense on top of that. Yeah, then I have, this is my Claude Code specific portion. I'll have a few general, oh no, I have alternatives. You can use Codex, Cursor, Droid. I guess the other Joonas will be talking about alternatives, so I'm not going to go too deep in these. And there are open source alternatives too. But they are likely more expensive because Anthropic is subsidizing. I believe Anthropic is subsidizing a lot of Claude Code usage. Some general notions. Where do we go from here? As a like software industry. Do you know what the T-shaped engineer is? A few of you know. Basically, it means like an engineer that has like a wide variety of knowledge, but like a deep understanding of some specific field. With AI, I found this image from McKinsey of all places. There's this a concept of an M-shaped engineer where AI allows people to or different kind of shape experts that AI allows people to have prowess in different or in a larger setting. You can probably intuit better than my explanation from this picture. Anyway, the AI allows me to have more impact and more reach as long as I have like a general idea of how some things work. So first, we think we may be outsourcing the small stuff. What if your project manager could just ask an agent to change like one text somewhere or change a button color without like having your software development team do that. So what if you could delegate the boring and repetitive work that you take part in? Whatever you do, all changes should have a human owner. So I don't think it's wise to have AI doing stuff if there's no humans overlooking it. How about quality? Is the generated code and architecture good enough? I think it depends. It depends on your business and what's your level of speed and quality is required. It's a business decision. Of course, you need to remember to do code reviews. Need to do security audits that you just don't get like blinded by the speed that these systems allow. And in a long enough timeline, of course, the quality of generated code will improve. Right now, it's like mediocre. Like an LLM is pretty much like a mediocre, like an index fund of sorts. It creates stuff that is like the average of its training material, but that training material is getting better. So I believe the better these agents get, the longer they take to run. It's actually the feature they evaluate the agent capability by how long stretches of time it can work, and the longer it works, the more powerful it is. But the more time you have while waiting to just forget what you were doing in the first place and get distracted. So we'll have like weaker reward loops when working with AI. 1 year ago, when I started with Replit, it was like 2 minutes, and then it was unable to continue. And right now, it can work like they say it can work 200 minutes without like asking for guidance, and it has lots of time to go wrong. So the planning is more and more important. So we need discipline, guardrails, that sort of stuff, and we need to follow good software engineering practices. And these models don't do that by nature. They are pretty good at like programming, but engineering is a lot more diverse set of skills. Security and risk considerations. Try the sandbox, Claude Code, or any agent. Don't give it anything critical in data-wise, no personal information and that sort of stuff. You need to assess the risk based on your company's risk appetite and the probability of something going wrong. But it's also a risk not to use AI at all and just not follow the trends. And risk is what you don't see, it meaning you need to be creative about or have imagination what could go wrong with these tools. Managers have been vibe coding forever. Someone take a picture of this and add it to your presentation. For me, I quickly found myself thinking like a product owner or someone who doesn't have time to actually look at the code and just I could feel the busyness of the product owners that I worked with in the past. So what if everyone was just vibing? I think we will be needing more management skills as engineers. We will be having less time to code and more time. We will be spending more time managing AIs, doing teamwork activities, communicating, planning, allocating these resources, we need to be able to understand how much agent time costs compared to human time, and be able to work with more complexity. So we will be becoming a middle management profession of sorts. That's my prognosis. And with that comes cognitive load. There's so much one person can do and manage at the same time. We are less likely to reach flow states when managing a bunch of agents. So we will need to be leaving time to do the basic programming work, so that we don't also at the same time lose the ability to do the traditional work and evaluate the machines. So maybe in a sense, at some points, we may need to be letting go of the code, in a sense that we cannot be obsessing with every line being perfect. We maybe need to, in order to reach like more abstract levels of thinking and planning, we may need to forget about building like excellent syntax. How will this affect consulting business? It will change. I'm moving past this because we are out of time. I do? Okay. I think companies will require consulting services for like the end of times. It will only change what kind of services they need. I think they will not need that much like this sort of programmers for lease sort of business, at least not in the same quantities that we had in the past. In general, there will be less need for human programmers. Like we have no need for human computers anymore, like we had in the 40s or 50s. But software engineering, as I said, is much more than programming. Cloud code can currently do some of that programming, but not the engineering part. So a few reminders. We need guardrails and processes that are best practices in our field. There's this term of human in the loop, but I'd rather see human in the driver's seat instead of just being part of the loop process. We need discipline to slow down when agents allow us to go very fast, and taste and judgment over generation, and generation means like Gen AI in this sense. Yeah, there's one link I recommend if you want to try out Cloud Code in orderly fashion. There's a few hours worth of video and a few exercises there. There are probably others, but this is something I tried after first going like full in without any help. Thanks. Yeah, you can connect me at LinkedIn. And now I don't know if we have any.
We can take 5
Yep. Okay. Any questions? Yep.
So I'm just curious about the quality part you
Yep.
just mentioned, and yeah, for me, codes is kind of like sometimes it's very sensitive. For example, if you change like field A, it will like sometimes it will change like field B or field C. So like how to make sure the quality? For example, is there any way to like do the test automation to make your quality better, or yeah?
Yeah, a few things come to mind. Of course, you can tell or describe your like code quality philosophy in the claude.md file, which is like the memory. It will have some effect, but of course, if it's not like a strong strong way to enforce anything. So it will go to the LLM, and you know what happens when you give instructions to LLM. It sometimes follows them and sometimes don't. But what you can also, or you should do, and it's more important when working with agents, is setting up your like code linting configurations and type checkers, and of course that's like more of the visual and static sort of gotchas. So you will not be, or the agent will not be committing like bad code. And then on the like logic wise, of course, make the agents write tests and maintain them and run them yourself at times. Those are some things that come to mind.
I see. So do you think it like sometimes it's kind of time consuming to use these kind of tools?
Sorry, what is
Time consuming
Yeah.
to use these kind of tools? For example, like maybe the code is not what you want. Like you need to like change it, and you need to like chat with the tool again and again.
Yeah, I think that's a common problem where you kind of try to use these tools. They don't immediately give you the output you require, and then you abandon them. But instead, you should like take a long view and try to build the context, the guardrails, the settings, and all the situation in a way where the AI has the best possible chances to to make successful code. And still, you probably need to let go of the exact implementation. Of course, you should validate it doesn't do anything that is like completely wrong. It's like working with a tireless junior developer who's like new to the field in a way. Cool, thanks.
Okay, we're starting. Hello everyone, my name is Joonas Kykkänen. This time that's the surname. I'm a consultant here at WonderDog. I've been coding since I've been a kid, but like professionally more like a decade or so. And at WonderDog, I do software development, software design, and then lately I've been doing a lot of these like AI trainings for our clients. So kind of like showing our clients of like what are these patterns that are emerging in like terms of like AI first or AI assisted or AI augmented development, whatever you want to call this thing that is happening at the moment. What else about me? Oh yeah, hey, not about me, but the topic. I noticed that on this meetup page, it said that both Joonases will present a coding agent tool. I'm not going to present a coding agent tool for you. There was no miscommunications. There was actually no communication about the topics. But me and other Joonas, we actually coordinated this stuff. But I think that this stuff might actually be interesting for you as well, or I hope it is, because this is like stuff that I've been thinking the past weeks, and I'm really excited to talk this stuff through with other people. I'm not going to ask who is using these tools, but I'm going to ask who is or has used GitHub Copilot in VS Code or in some other environment. Okay, and those who are, can you keep your hand up? Those who are used. Who of you have used these custom instructions files? Some not. Okay, all right. How about cursor users? Can I say cursor users? Hand up. Have you used rules in cursor? Some, but not everyone. Cool. How about Claude Code? Joonas mentioned Claude's memory. There's like different terms for this, like the same thing, but like the Claude MD. Who has written a Claude MD file? Or who, by the way, who is even using Claude Code? Much less. Okay, and who, and those who are using, who's using Claude MD files? Yeah, cool. Then do I still have some example tools? Yes. Codex users, OpenAI Codex. Yep, some, I expected this, not many users. Have you used agents.md with your Codex? Yeah, cool. Yeah, Agents MD, it's got like open source format, but that's the one that Codex is using by itself. Oh, we have more. Gemini CLI users. Okay, cool. Have you done these? What are these called here? Context files. You know, not no. All right. So last week I was at one of my clients. We had like this 2-day training, and I also got to see kind of like how is this client doing this like AI assisted development inside their organization. And of course, when we have done these trainings, we have also gotten to kind of like have these like sneak peeks inside organizations. And I can tell you, every organization and every team is also like super interested what the other teams are doing, because it's like, you know, this stuff is super new. We don't have yet this definitive book about AI assisted development. So everyone's still kind of like interested about what are other people doing. Now, the thing that I saw at this client last week was that, okay, like, or first of all, this client, I would say very high on adoption rate. So very mature when it comes to adopting these AI assisted development tools. Meaning, if you were a developer at that organization, whatever tool you wanted, you got it. You just ask your manager like, hey, I want to use this. Cool, here it is. If you're worried about the token usage, the manager will tell you like, hey, let's worry about that later. Just like try it out and see how it is. And of course, they got training from us to get people even more kind of like powered up with their skills. Now, those, can I get hands up again? Those who have written any kind of like custom instructions or rules in Cursor or Claude MD files, I know there were many of you who written those. Who of those who are like done those things, are you committing those files to Git? Can you keep your hand up? Yep. And do you work in team context? Yep. So what's the decision process inside your team when you commit something to Git when it comes to rules? Yeah. Yeah. Yep. Yeah. 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 Yep. And that's what I've also observed. There isn't this kind of a big scientific process happening inside teams where rules are peer reviewed, but it's like, hey, something seems to work, so it gets committed. Or sometimes people don't even test these things. It's just like, this makes sense. This type of rule makes sense, so let's commit it. Then what I've also noticed is that some teams don't commit their rules at all. And I don't know why this is. It might be because the usage isn't like 100%. So people are kind of like concerned if their colleagues might, for example, judge them that you're showing that I'm actually using Claude code here because I'm leaving this Claude.md file here. These different tools and companies, they give you like instructions of like how to write effective instructions. They're kind of like, they don't copy each or like parrot each other word by word if you go to these different documentation about these instructions and rules. But what you will see is you kind of like find the same exact stuff. Usually people talk about like, oh, you should be describing about like what's even happening in your project. Then like if there's any kind of important structure that the coding agent should know. What else do we have here? Coding standards. Those are typical things to add in the rules. Then yeah, include any specific tools, libraries. Yeah, super helpful information for agents. The reason why I put Copilot's instructions here, because unlike Cursor or Claude Code or Codex, Copilot also it talks about like what you should not add into your rules. So this means that, okay, hey, don't, for example, add this kind of like tone of voice to your agents. Reason being that these prompts get added, or like these rules get added to your every single prompt. So every time you kind of like send something to Claude models, this stuff gets kind of like copy pasted inside your prompt. So even though you don't see it, but under the hood, all of this stuff gets sent every time. Therefore, you want to have something that's applicable to most of your requests, because otherwise you might just like get bad outputs every now and then. This is the agents.md example file. This is what they look like in practice. After seeing what other organizations are doing, writing their files, I can tell you also like, hey, everyone's rules look like this. There isn't this kind of like magical alternative way of writing their rules. Everyone is kind of like coming together in terms of like writing the rules in this same way. Of course, probably influenced by the fact that this is how the companies such as Anthropic tell us to write our rules. Regarding that Git committing and whether you Git ignore, I think it's like interesting that Anthropic doesn't like tell you that these things should be in Git all the time, but it kind of like nudges you towards committing these rules to Git. And I have kind of like seen similar type of wording with other companies regarding this. I don't know if it's because of like, it's a form of viral marketing. You see all of a sudden this Claude MD file popping up in your repository and you're thinking like, oh, what is this? Or is it because this is like something that these companies think that it's actually like super valuable to share? Claude Code lets you add local files. So you can do, for example, claude.local.md, and Claude Code knows how to read that file out of the box. You don't need to add any other logic. And then in your git ignore file, you can do like star.local.md, and then your file gets ignored. But I think, for example, and please correct me if I'm mistaken, but for example, GitHub Copilot does not have these kind of local files. Agents.md doesn't have local files. So the way if you would want to do local files with these things, you have to do symbolic links. So you kind of like commit, for example, the agents.md to your GitHub repository. And when the developer clones the repo to their computer, the agents.md actually points to another file where they have their local files. But, it seems that these companies are not necessarily making it easy to have just local files. There seems to be some value in having these things kind of like shared. Now, I'm going to jump to something different. I'm going to talk about context, which, Joonas, big appreciation for you explaining some of these concepts. So I don't have to like talk about these concepts now. But context meaning like all of the stuff that gets kind of like accumulated as you talk, as you have like a chat session, for example, with a cloud model. It includes your previous messages. It includes any kind of like pointers you have given it to the files. And since it has access to your code base, it might go to your code base and get some stuff from there and add it to the context under the hood. Now, these models are like maybe like 1 year ago. I don't even remember like what has been the pace of development here, but I think like 1 year ago, the big problem with context was that you couldn't fit your whole code base into the context. So the reason why you gave a very little bit of context was because the context grew out of hand, and then it couldn't fit into the context, and then the model couldn't help you anymore. But now we have these massive models that have context windows of 1 million tokens, 2.5 million tokens. And in practice, that means like 4 books stacked on top of each other. I'm pretty sure that many of us here who work with code repositories, our code repositories, like your individual repositories, could fit into these context windows. So if you can put your whole code base into the context window, the question you should be asking yourself is, well, why don't I just like point the code agent, for example, Claude Code, to the code repository, give it the task and let it figure it out? Like, why do I have to sometimes reference specific files or folders? Is it because the LLM is dumb, or is there something else that's happening? Who here has heard about this concept called context rot? Some. All right, context rot is like this problem that starts happening when your context grows, when it becomes like quite large. The example that I have here is about, like, the paper is called, I think it's called like Cat Attack, the paper. And in this paper, the researchers tried to kind of like break these models on purpose to kind of like see like, okay, if we give the model this type of mathematical challenges that should be kind of like easy for our modern LLMs, how can we break them on purpose in like very minimal ways? So like the first example about the redirection of focus by general statements, that makes kind of like intuitive sense to us, right? We're giving it the model like a mathematical problem, and then we give it some other numbers that don't have nothing to do with the problem. We all have seen the LLMs kind of like get things mixed up, so we can kind of like understand why we don't want to introduce extra numbers to these mathematical problems and why it would kind of like take a misstep when calculating this thing. Then we have the number 3, the misleading questions. Again, we can see why that would like trip up the model. But then we have like unrelated trivia, which to me is the most interesting part. Like, why does that trip up these models? Here you can add this like interesting fact about cats, and the solution of your mathematical problem changes. There's like, we don't add any numbers, any other kind of distractions. We just like say like, hey, here's an interesting fact about cats. The number changes. Other types of context rot that can happen is that, well, first of all, if you have like used these like agents, you see it like working, doing like different tasks, something doesn't work, then it changes its like way of working, tries something else, and then it gets back to the right path and starts like making progress. Do you know what happens to those answers that were wrong? Ideally, those answers get ignored, but sometimes the model confuses its past wrong attempts as valuable information. Again, one type of context rot. You're like, if it's like trying this like big loop, takes a misstep, redirects itself, but all of a sudden it starts thinking like, oh yeah, this one bad thing I did, that's actually really important, and I should like try to focus on that one right now. Then the Google AI team, when they were like, before they announced Gemini 2.5 or around that time, they were playing, Google and Anthropic were kind of like competing in Pokemon Yellow. At the same time, Anthropic was putting its models to play Pokemon. Google was putting its models to play Pokemon. And Gemini 2.5, what they found out was that the more information the model had about Pokemon games in general, the worse player it would be. It would kind of like mistake things that you should do in these games. It was playing Pokemon Yellow, to be specific. It would mistake things that happen in Pokemon Red or Pokemon Blue, and then do these weird things that didn't make any sense in the Pokemon Yellow context. Sometimes we think these models as kind of like, or we like, how would I say, we try to rationalize what these models are doing by kind of like finding analogs about human minds, or like how human memory works. But this type of stuff it's kind of like counterintuitive, right? Because you would think that the better human Pokemon player would be the player that has played all of the Pokemon games before they start playing the new Pokemon game, right? But what the Google team found out, that when they prompted the model to kind of like forget everything that you know about Pokemon, now you're going to start playing Pokemon Yellow, that model or that prompt would outperform the model that kind of like had access to the training data about Pokemon games. What they also found out in this like experiment was that the larger the context window grew as the player or the agent player started adding like the player actions into its history, the larger the context grew, the more repetitive it would get, which is not something you want the kind of like an effective player to be in a video game where you're like discovering how they should approach different challenges. You want the model to try out different ways of working on things, but it turns out the more context you added to this model, it was just kind of like tried the same thing over and over and over again. Yeah, these are kind of like the typical stuff of context rot, and this is why we have to be like very careful about our context, because otherwise we might be seeing these kind of issues. Then, who here has heard or looked into prompt engineering? Right, prompt engineering is this kind of like practice, this art and science of trying to build better prompts for, to get better outputs. And the terms that you might have heard that relate to prompt engineering is chain of thought. Here it's abbreviated as COT, meaning that, well, you don't need to do this now anymore with these like new reasoning models, but with older models, you want to sometimes add to the end of the prompt, let's think this step by step when you're doing a complex task, because that would trigger this kind of like reasoning pattern. That was called chain of thought. Then you might have heard about zero-shot prompting, one-shot, two-shot prompting. Zero-shot meaning you don't give any examples of what you expect the output to look like. One-shot, two-shot meaning that you're giving like one example or two examples. What else? Personas, you say like, hey, you are a senior developer, and now you have to build this React component for me. Idea being that, a senior developer builds a better React component than a junior developer. there's like 2 papers that I found that kind of like studies on like this is like a controlled study about these prompting techniques in the field of software development, because that's the part that's interesting to us here, right? And both of the papers kind of found that, you know, the results so and so, you can't like really prove that this stuff works. And in sometimes it also kind of like it would backfire. So if you would, for example, do persona and zero shot and chain of thought, the output would be worse than you did like none of those things. So it seems to be kind of like this thing that sometimes works, sometimes doesn't work, more importantly, sometimes feels a bit random. One caveat with these studies, so before you think like all of this stuff doesn't make any sense, of this prompt engineering stuff, big caveat with these studies is that they only looked at like function generation. So when you're generating just a single method, they didn't look into like these more complex tasks. And if you have asked, for example, Copilot to generate a method for you, you might have noticed that in order to get a nice Fibonacci method, you do not need to tell it that you are a senior algorithm expert and let's think this step by step, write me a Fibonacci sequence. You can skip all of that stuff and just ask the function. And by the way, if you're wondering like, oh, did any of this stuff work? The stuff that seemed to work on a statistical scale was if you're creating methods, define the method signature and output that you get. That tends to result into better results. Joonas, you did not talk about, you didn't compare Claude Code to any other agent, but let me ask you, which one is better, Codex or Claude Code? All right, which one is better, GitHub Copilot or Claude Code? Have you used Cursor? Yeah. Okay, which one is better, Cursor or Claude Code? Yeah. 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 Yep. And that's how it is for all of us. Like we don't have time to invest personally, like to calculate which agent is the best. However, if me or the other Joonas would give like a talk on a big stage about like which agent is the best, we would have to talk about evals, which is like this fancy word that just means evaluations. And evals, like the first time I started looking into evals was like last year when we were building a chatbot with one of our clients. And then there I learned about this like evaluation pipeline. So for example, like when you're building your chatbot and you know what type of user prompts you are getting, it's really nice to kind of like build this pipeline where you can send, let's say, 100 different real life user prompts to that agent, and then you evaluate what kind of responses you get back. If you don't like the tone of voice, then you adjust, for example, the prompt, and then you run that evaluation again. And if we think about, for example, doing these type of like these studies, we would use these like evaluation pipelines here as well. We could define that, okay, this is what the end function should look like, or here's like the automated test for validating this function. And let's just do 1,000 different functions. Let's try different prompts. Let's automate all of this and then see which prompts were the best. Who of you have looked into these leaderboards about like checking like, okay, which model is the best? Which agent is the best? Some. Can you shout out some leaderboards that you have checked, like names of, if you remember? Yeah, well, SWE Bench is the one that like at least the big AI companies love to refer. It feels that now this is kind of like now the top of the class in terms of like leaderboards. There's also Aider Polyglot that sometimes gets referred. Aider Polyglot, that leaderboard only focuses on this kind of like lead code type of challenges. So for example, generating those Fibonacci methods or other kind of like this like tricky programming challenges. The SWE Bench, what they do is they have, I think it was like 50 different open source Python libraries. They check real life pull requests about bugs. So issues about bugs. And then they send out these models to solve those issues. And since they have kind of like already the kind of like the right solution available, implemented in those libraries, and they can easily validate how good of a job that agent did. The other cool thing about SWE Bench, or it's cool depending on what type of information you want to get out, is this SWE Bench is always a combination of a model and tooling. Okay, actually, I'm showing the bad example. I've like highlighted the bash only stuff. That's like less interesting. The kind of like the full comparison is more interesting, because there in the bash only, it's kind of like this minimal agent that's highlighted there. It meaning that, you know, it's like a light touch on top of the model, kind of like directing the model's work. And then when you add more tooling, you get into this competition of like, okay, what is better, Claude Code plus Sonnet 4.5 or Codex plus GPT-5, which is like the hot question of this week or last week. Next week is going to be some other tool and some other model. There's like one paper that looked into this kind of like the problems of SWE Bench. What they found out that, hey, it's kind of like it's good for measuring real world agentic coding skills. However, you know, the problem set is very limited. It's gonna take like 1 hour to fix for a human engineer. We're not talking about this kind of like examples that Joonas showed earlier here, like building these like complete websites. Then there is kind of like this contamination risk, meaning that, guess what? These open source libraries are now part of the training data of this neural model. So it also not necessarily like about checking like, okay, which model is the best developer. It's also now more of a test like, okay, which model remembers the best of like what was the right answer. And then if you remember earlier, I said like some people think it's cool that you can add tooling to it. Some people don't. It says here the scaffold build. So the scaffolding is the tooling that determines benchmark performance as much as the model's raw capabilities, meaning that it really matters what type of tooling you put in front of it. But to me, that's cool because it kind of shows that, hey, we don't need to do innovation only in the LLMs. We can also do innovation in the tooling. And that also, like, these differences seem to matter. Like, you know, earlier you were like, when Claude Code came out, you heard people talking about like, oh, Claude Code is so much better than GitHub Copilot. And it's kind of like, and when you maybe tried it your first time, you felt like, yeah, it feels better. So it's kind of like cool to see this validation that the tooling and the scaffolding does matter. But we don't have an actual benchmark for these agents, right? SWE Bench, it's only Python, it's only bug fixes. So we can't actually like duel these agents against each other. And that's kind of like going back to the very beginning when I was talking about the rules and other stuff, and then talking about the context rot, meaning that if you have a bad rule somewhere, that might result into worse outputs. And defining a bad rule is really difficult because some of these practices, sometimes they work, sometimes they don't. Sometimes what we feel is like a helpful rule might actually be not a helpful rule at all. And if you think about, if you start with one single rule, that's a really easy situation to manage. But if your team is committing rules, I believe that 1 year from now, you're going to have like 50 lines of rules and you have no idea what's your actual performance. It might be that your agents perform better without any of those rules because you might have like crossed the chasm in terms of like when like reached the peak of what's helpful and then it's been like downhill for a long time. So kind of like seeing how our client was like working with these rules, like adapting these new agents and committing rules, it kind of occurred to me that 2026, especially with these early adapter companies, the problem that they're going to be probably struggling with is like, okay, which rules should we keep and how do we evaluate these rules? So I'm personally building currently like my own personal evaluation set just so I can also like, you know, try out different things and kind of like have like a better feel what seems to work, what doesn't seem to work, instead of like just the evaluation being super context specific. For example, like Joonas said earlier, he uses Cursor for something different that he uses Claude Code for. Therefore, it's not fair for Joonas, for example, to say like, oh, which one is better, right? Because the context changes. So I've been thinking like, okay, how can I build like an evaluation set that would be like a little bit more fairer for these agents? The one paper I found, this is already like last year, so it seems like super old, but I feel like it still has probably some value, especially for this talk. It's Microsoft team, this guy Copilot evaluation harness, like their suggestion of like, how should we evaluate these agents? And the rest of the talk, I'm thinking like, hey, let's just like go through these like ideas that they have about how we should evaluate these agents. Now, again, the questions that they're wondering is like, okay, how are the prompts phrased? Because you can change that phrasing, right? So meaning in your team context, it means like, how do you phrase your rules? Like, you know, do you put a must not do this, or do you put capital letters or import words like important there? In what order is the information given? It doesn't matter if, you know, important rules are in the beginning or in the end. That might matter. And then what context is provided? You know, in your rules, do you refer to certain files, or just in general in terms like in your working context? What context do you want to give? So there are, I'm going to present now the general areas of software development that this team looked into, and kind of like the evaluation areas that they feel like kind of like it should be, how would I say, separate or taken into consideration. The different parts of our work, right? Like we don't always do the same thing as a software developer. The first evaluation set relates to documenting code, right? Generated documentation. LLMs are really good at this. This is their example for it, right? You have your Fibonacci method. Idea is that if you write this doc command, you would get that type of documentation out of it, right? And that would be like a nice documentation. These are the metrics that that team looked into. By the way, I'm just like showing all of the information that was available. The syntax correctness, I don't think it's an important aspect in today's talk, because that is just checking that, hey, did the documentation go into the right place in the first place? It seems that with these like newer models and newer tools, we don't need to worry about does the documentation go into the right place, more about like, okay, what is the quality of the documentation? All right, so the syntax correctness, meaning that, okay, it's in the, or it doesn't break the syntax of the file. And then the format correctness, what do we see here? We check the correctness of documenting the return statement, function arguments with their types, function name, and whether a function description was written. That would be kind of the evaluation, right? How do our docs commands work? Bug fixing is like its own area in this paper. Can anyone spot what the issue is here? Oops, E and I are in different places. I wish all of my bugs were this easy to fix. These are the metrics. Again, syntax correctness. Yes, the bug fix doesn't actually break the code file, but then the fix rate is like the more interesting metric here. So we check that an existing static analysis warning or error in the code has been successfully resolved by the suggested changes without introducing any other errors. So we could also automate this type of check. Like we give 100 different bugs, we see what the fix is, we evaluate whether that issue is fixed automatically. Then the kind of like the interesting stuff, generate code generation from natural language. Meaning that, okay, we tell the agent to write as a Fibonacci method, and then we check what it provides for us. Again, we have this syntax correctness. Yes, the file should actually be able to compile or whatever. But then the way we evaluate the interesting part is with this like test pass rate. So we check the number of passing and failing tests and compute the passing test ratio. Then we do test generation, also really easy with LLMs. Here's our method. We ask it to generate that test for us. Oh yeah, the reason why there isn't a prompt is because that prompt is, of course, underneath that command. Of course, the team doesn't want to show you what are their exact prompts when trying these things out for commercial products. Here, again, syntax correctness, but then the interesting part, generated test pass rate. So we assume the original method is correct, and then kind of like execute generated test on that. For this one, I kind of felt like, yeah, it's better than nothing, but in here we can also kind of see why we would get like false positives, right? Because you could have like a test that doesn't actually test anything. It's just like always green, no matter what. Last area is this kind of like workspace understanding, meaning when you're moving to a new team, opening like a new GitHub repository, and you have no idea what on earth is happening here. You check the README. Of course, the README is out of date. And then you're going to start asking your agent questions about like what is actually happening here. Here we don't have syntax correctness. We have this like mean reciprocal rank. First, I was like, okay, that's like math. I don't understand this part. But it's just checks that, okay, what was kind of like, was the right snippet fetched and in what order was it fetched? And just you can calculate like a simple metric from that. And then we have end-to-end keyword detection. What do we have here? Yeah, rank list of retrieved snippets and pass it to the model along with each user query. Then we detect whether or not the associated keyword appeared in the model's response. I have to admit, I did not like fully understand exactly what's happening here, but you know, I would want to add these kinds of evaluations for my agent evaluations. This is what the data consists of for this team, made up of methods from hundreds of public GitHub repositories across 6 languages. If you would need to implement this for your team, I'm pretty sure that your team has other better things to do. This might take a little bit too much time to get a possible 5% improvement rate in the outputs of your agents. So that's not something that's actually like realistic, I think, for teams to make or like build. And then kind of like, okay, well, how did they actually do these things? For dogs, they kind of like, identified methods that are like longer than 3 lines, but don't have like any kind of doc strings yet from those public repositories, and then ask the agent to generate one. For fixes, you can run they could run some like analysis tools for warnings and errors for those public repositories and then generate their data set from those. For generate, and kind of like, again, going through the public repositories, finding places to kind of like add those new functionality. Same with tests. And then for workspace, it was actually something different. We collected questions from developers about certain aspects of their project workspace, such as the idiomatic way to build a certain feature. And then you can put those ones into evaluations. This team didn't want to use LLMs to evaluate outputs. If you have ever done like a pipeline where you do use the LLM to evaluate the outputs, you might have noticed that the LLM, surprise, surprise, sometimes gets these things wrong. So therefore, if you are, for example, building this commercial product, such as GitHub Copilot for millions of users, you want to have a little bit more trust in your evaluation set, right? So they, for example, ignored completely LLMs as kind of like a valid option to do this evaluation. However, I'm pretty sure that they have to have at some scale, right? Some kind of LLMs in some evaluation pipelines. Anthropic has built this kind of like a multi-agent research system, so you can do now kind of like these research jobs in kind of like at Claude.ai. And the kind of like the cool thing with this research system, as like Joonas mentioned about those sub-agents, and sub-agents are a multi-agent system. And the reason why multi-agent systems work so great with research stuff is because if you've ever done research, you might have noticed that you never know where you're going to arrive in your process, and you don't know exactly how long it's going to take to find out the answer. And earlier, you noticed that, okay, it's bad to have like large contexts to pile up. And you don't, and of course, if you're like providing these type of tools for people, you would like to know like how much context are we going to be kind of like generating with this research stuff. And sometimes you go on tangents when you're doing research, and throughout those tangents, you learn all about all like cool new facts and other factoids, but you still only need that one piece of information. And as a human, you can kind of like ignore the other stuff that you learn, or you tell about your friends about those things, but you don't keep them in your final paper. But these agents, of course, that stuff is going to hang around. So if you send an agent for a tangent and it takes a long time for them to find an answer, you're kind of like poisoning their context on the way. So with multi-agents, what the main agent can do, it can kind of like spawn these sub-agents that go find out answers to specific questions. And then that sub-agent can have all of that context right inside of it. It just needs to answer one question, and the main agent can kind of like keep collecting answers to specific questions and making sure that we're arriving at the right goal. The reason why I'm talking about this is because these kind of systems are super fragile, and so fragile as that. For example, when we do our trainings with the sub agents, we say that, hey, if you want to try them out, go ahead, try them out, but no one should feel FOMO about them, because you don't necessarily know if they're going to work all the time the way you expect them to work. And like with fragility comes this kind of like big opportunities as well. Since it can go wrong really bad, it means that it can go really well. Or like the different, kind of like the delta between the worst output and the best output is really big. And therefore, these kind of like tweaks that you can do improve the kind of like the success rate really like a lot. But evaluating multi-agents is really difficult, because it's not like you don't know which steps it's going to take, what sub-agents it's going to spawn. And therefore, doing this like a simple 1,000 different inputs pipeline where you get like 1,000 different outputs and then tweak your things based on those outputs doesn't work, because the variables inside of like what happens between that input and output is too big. And this is what they also said in the article. Like, teams tend to delay creating these evaluation sets because they feel like, hey, you have to have a large evaluation set. You have to have hundreds of public GitHub repos before it makes any sense to build an actual evaluation set. But they actually found like success by doing this like small scale testing with few examples. And if you watch any of those like interviews with Boris, I can't remember Boris's surname, but kind of like the lead of Claude Code. Boris talks often about how they're kind of just like vibing the development. They don't have this like super systematic evaluation set where they're like checking like, okay, what makes sense, what doesn't make sense. They're dog feeding themselves. And based on Claude Code's success in the marketplace, it seems that this approach works pretty fine. You don't need that large set. And hey, this is actually where I'm like ending my talk. Just kind of like food for thought for next year. And if you are committing rules inside your team, maybe you're now thinking like, oh, maybe we shouldn't, or you know what, maybe we should, just keep adding these rules. But hey, any questions or comments at this point?
How many of you? Anybody questions?
Yeah, so as my own opinion about all of this has been for the last year that it's mostly witchcraft. But yeah, so maybe the question is like, when people now try to tweak the models to be, let's say, 10% more effective, like, does it make sense as when people still think that the next model will be even better? And do you in the future, like 2 years from now, need to have any of this extra context, or it will just figure it out?
Yep. So does it matter if you kind of like do these small tweaks now, because the next model, for example, the chain of thought thing, you don't need to know it anymore. So why think about that stuff? Or like, let's say zero-shot prompting now, because you might not need it in the future. And I agree with you. Maybe you don't need to think about that stuff. But then the big question is like, if you have a rule set that you do not know whether it improves the output or decreases the output, and it also in the future it might become completely invalid, and you spend your team's time in discussing whether a certain rule should go in. Does any of this make sense? Is all of this just like big waste that you are kind of like generating?
Exactly. Like I understand giving it some like really simple rules, but in the way, as you said, like there's probably no point of giving like hundreds and hundreds of different rules. But yeah, it has been my whole thought for like a long time now that new products come with their own approaches, and they just seem to be like this wrapper on top of a wrapper and no one really knows like are they improving at all like in the end. Like many people started using Cloud Code and it was the best thing ever. Then 2 months forward, it's people getting angry with the product that it's not as good as it was, but I think it's just placebo. Like
and nobody is able to kind of like provide the quantifiable numbers because we don't have like a good evaluation set in the community at the moment to kind of like show like in numbers you can see that Cloud Code used to be the best, now is
But yeah, that's it. Anyone else? Yeah.
Okay, so I was reading 60 papers about the topic, so I might have some questions. Okay, let's number one. So do you think we end up with autopilot instead of copilot? Do you think we end up with autopilot so that you don't do coding, you just do specification?
Yeah, like, you know, are we going to be completely like hands off in terms of developers? Yeah, not necessarily something I talked about in my talk, but it was great that Joonas pointed out those things. And of course, I also have an opinion about that stuff. Based on like what I see, like what kind of gains people get the way they work, I feel like the more hands-on you stay with this stuff, and in kind of like smaller increments that you work in, you do like this step-by-step development, the better outputs you get, especially when working with legacy code bases and larger code bases. And if you want to work step by step, it means that you sometimes need to go into the code yourself and kind of like understand the code and like kind of like tell like what needs to happen next. And if when you see like a bad output and it's just like a couple lines wrong, it doesn't make any sense to like prompt the agent to try to get it right, unless you're experimenting with these things, trying to like learn how they work. So it's just easier to like fix it yourself. And therefore, I think that there's like kind of like no less software development skills needed next year. Maybe less about code syntax.
I mean, my feeling is we're moving from software development to engineering. So engineering is becoming more important. And I think we're looking at things like understanding requirements, modeling. How do we model domains and so on?
Yeah.
Any other questions, or should I keep going?
So we've been talking about the foundation models, the large language models. How about the purpose-built smaller models that are coding specific?
Like for example, now with Cursor 2.0, the what is it called, the new one?
I don't know. That was just released last week. I haven't had time.
Yes, Composer. Nice, thank you. Yeah, so Composer kind of like specific build for programming. I don't think like, is it so that Cursor hasn't told how it's been built, but based on like what's available in the marketplace and their company size, my bet would be that they bought kind of like a team that had a foundational model and like paid them to build a specific model for themselves. But aside that, sorry, what was your question?
Yeah, how about will those like coding specific models like become better than like all-knowing?
Yeah, that one. Yeah, models? So I don't want to like kind of like speculate on that, because that part seems to me like that's easy to quantify. Because I would say like, hey, whatever model performs the best at the either polyglot or even on SWE bench, that's the kind of like the best model. But then like it gets so much more difficult when you start adding the scaffolding and the tooling and the agentic stuff on top of it. Then it gets like super muddied.
And I guess my follow-up question or idea is that when these smaller models are getting better and smaller, will we be able to like run them on our laptops eventually?
I have not looked into kind of like the computational stuff because I'm like not interested at all about RAMs and processors. Has anyone here like tried to run models on their computer? So what's your take on it? Then, for example, NVIDIA is now coming out with this kind of like more consumer market targeted products that could kind of like, you know, let you run even bigger models or like that you can currently run. instead of like, for example, having to like come up with these like smaller models.
My turn. Yeah, good catch. So I guess the question is, let's say you're trying to get into the industry. I think now it's somehow difficult to even find entry-level jobs. What will be like the kind of the skills that you should learn if you're trying to get into software development or in the industry?
Yeah, so there's like different theories, and Joonas pointed out, for example, that M model, and that's something I've also heard, and especially about like this, I've heard that the next years are finally going to be the years for generalists, because people have been talking about years and years how generalists are the most valuable people in organizations, but there's no career tracks for generalists. Generalists just usually end up in management positions. But with these models, you can kind of like know more about more stuff, meaning that, you know, you don't, as a generalist, you don't need to know the exact coding syntax about stuff, because like the models can help you there. And because of that, there's this speculation that, you know, the generalist skills are like the most valuable in the current workforce. But that stuff being like, people have talked about that stuff like, I guess, for a decade already now. But, you know, like I think the generalists are complaining that there's no jobs for them. So I wouldn't tell anyone to kind of like say that, okay, now it's going to be different.
All right. Do we have more questions?
My questions are about the fact that we want to get consistent results, right? The evaluations would lead us to get some kind of convention that everyone can follow to get consistent results. Like, since you've been consulting with companies who are, you know, on the forefront of doing these things, has anyone experienced good things with spec-driven development, where you ask it to write a spec first and then you commit, and that becomes your documentation, and that's the source of truth, and then the specs are the instructions, basically. You just say, okay, implement the spec now, and then you're just modifying and changing the spec with your requirements. Have you seen people use that, and has it been successful?
Yeah, so it is in our training materials, because we want to show it, because that's like a pattern that has also emerged in the field. And again, like if you haven't used spec-driven development before, instead of like doing the normal planning and then implementing the stuff, you just add extra steps. For example, you collect requirements without any kind of code exploration first, then you do a technical design, then you build a list of tasks that are actually LLM prompts that you feed to the LLM one by one. That stuff is like, tends to be kind of like newer stuff for people. And then, for example, last week when people were then experimenting with stuff and with that stuff, and we asked like, hey, what are the first impressions of that? I feel like the impression was like, so and so, or leaning more here. But when I saw like how people used spec-driven development, I noticed that people try to put too much stuff into the spec-driven development workflow, because it promises a lot. If you look at articles where people talk about this stuff, it says like, okay, now you can add more specifications with this stuff. And when you add too much stuff, you end up with these specs that are so long that you get bored reading them halfway through. And then they're also maybe too big in terms of context for the LLMs, even though they can like handle it. It can go in the window, but then you end up with these context wrap things. So therefore, I don't know, like whether it's going to be actually like an efficient pattern or not.
Thanks.
Cool. Do we have anything to add, or should we just wrap up the session? Do you want to say anything to your audience?
I have like 3 more hours to like talk about this stuff, but I need to like stop here.
So where will you go next if you want to learn more about this topic?
Yeah.
Do you have a specific resource online, or how do you learn about it? You read papers, or what's your tactic?
Yeah, so because I learn about this stuff to have like stuff for the trainings, and we don't want our trainings to be like, oh, Joonas feels this way, or Ville, who is one of our trainers, not our CEO, Ville, or Ville feels this way. So we always try to find like a research paper to back something up that we have seen that works, or at least have like anecdotes from clients or like actual other people that, okay, this seems to work with people.